Hello everyone, hope you all are doing well. This is a part 3 of the series in competitive programming, in which I am trying to cover everything in this series, including algorithms, STL data types, which are required to be good at competitive programming. I have already made video on vector, important inbuilt functions of algorithm library that are very helpful. So do sub, and more interesting videos are on the way. In this tutorial, I will cover on where to use the unordered map and where to use a normal map. If you guys want to know about map, check out part 2 of this series. Cause in this video I will only discuss about the difference. As in case you can see here that M1 is a map and M2 is an unordered map, and I'm going to insert data in them, something like this. I'm inserting in this part, I'm inserting in the map, and in this part in unordered map. Now if I'm going to run this thing, let's run this thing. Then just by looking at the output you guys can get an idea of why this thing is called only map and this thing is called unordered map. As we had inserted, in case of the map, in some juggle was there, and so the data was stored in a sorted order, and that's why the display is been done in sorted order. But in case of unordered map, the map is not sorted and is displayed just like I had inserted data, or maybe in some different way. So there goes the first difference. Even if you want to use map and unordered map, you need to include the libraries. They both don't come in a single library. As by juggling, I meant the data was actually not in sorted order. Like at first A was being stored, then C, then B. But as you guys can see, it got sorted, and so A, B, C. But in case of unordered map, the data was in some order which was not sorted, of course. And here you can see again the data is stored in some particular way which is not sorted. Okay, so now we are going to discuss the difference between STD map and an ordered map. There are 3 points that I'm going to discuss now: is implementation, memory usage, and time complexity of these three. The first one will be implementation, like how are these internally implemented inside the memory. So STD map is implemented using a BST, actually a balanced BST. There will be like binary trees, and these trees will be like balanced. This will contain some values, and all these trees will be balanced. What does that mean by balance? That each of these nodes will have two nodes of their own, two child nodes of their own, which is left and right. Okay, so there can be some case arise where a particular parent node won't have any child node, then also it can also be balanced. But we need to see that the leftmost, something like this has to be present. For example, this this thing is possible as the leftmost parent node has two child node, or even something like this is possible, as the leftmost, the node that we are getting should be stored at the leftmost, then only this is called a balanced tree. Now if we do something like this, like add it here, by leaving this thing empty with adding no right nodes, then this is not a balanced. So this is how actually STD map is implemented. The correct way will always be something like this. So now moving on to unordered map. In unordered map is implemented or store elements using hash table. Therefore the element will not be stored in any sort of sorted order. They will be stored in any kind of arbitrary order. And the process that is used basically is hashing. Now in hashing you will have a um, key value, like something like 1 2, and they will have the respective values, like 2 has B, 1 has A. And you will have an hash function. Now what hash function does is that if you're going to supply the key value, that is 1, so 1 minus 1 will be 0, and this 0 in the hash table, in this hash table, is going to store the value. Similarly, if you're going to supply 2, so 2 square is 4 minus 1 will give me 3. So at 3, it is storing B. But now there is some problem here, is that if you're going to supply minus 1 here, then this will again, the hash function will again give you 0, which is called collision, because there is already uh, value stored at this position 0. You don't need to actually worry about this, because it's internally managed by the system. So now moving on to the second point, which is time complexity. Now time complexity for searching an element in map is actually big O of log n, because we need to traverse the whole tree, and it doesn't matter whatever you do, whether it is searching, deletion, or any other operation like insertion in a balanced tree, it will always be the time complexity of big O of log n. Now in case of unordered map, if you're going to search for an element, let's say a key value supplied to you 1, then you're going to put the 1 over here, and you are going to get the value of where this value a is stored. So 1 minus 1 will give me 0, and we will get this thing out of this. And so the time complexity in the best case scenario will be big of 1. And moving on, if we, let's say, collision occurs, for example minus 1 is given to you, you're going to put minus 1 over here, then you're going to search an element and you see that the element that you're searching for is not present here, then uh, there may be some other kind of searching may occur, like a linear search or maybe hashing again. So in the worst case scenario, it will be big O of n, that is n will be the number of element that is present in the list. So now coming on to my third and final point today, which is what to choose between map and unordered map. When you need actually low memory, then unordered map actually consumes extra amount of memory for internal hashing, so you should prefer map. Now if you are interested in ordering too, then you should also go with the map, as it stores data in a particular order. Now when you need guaranteed performance, then also you need to choose map. Well, you can may ask me like, searching an unordered map gives me like big of 1, then how is the performance of this map is better? Well, you need to consider the worst case scenario also. In case the worst case, it goes for big of n, but in case of this map, it is big of log n, so I prefer to use this. Now when to choose unordered map instead of map? Well, there is kind of a basic trade-off between the unordered map and the map, which is basically, if let's say you have a huge amount of memory, you don't need to worry about it, then you can go for unordered map any day. And also if your hash function is good, then the complexity you will get is big of 1. Adding a couple of more things here, if there is another way of displaying the map, something like this. And also if you want to find an element by using the key value, then you can do that by using this dot find function, the map name, then dot find function, and then the key value. It can be string, integer, or anything. If let's say the value is present inside that map, then it is going to return a pointer to that particular value, elsewise it is going to return a pointer to the end. And that's it for this video. Thank you for watching. Share it with your friends. Bye bye. Peace out.